Okay, welcome back. We're going to continue dissecting the rigid body system here, and we're going to look at something else here, some other parameters and properties, and keep going from there. Okay, for the next set of parameters, what we're going to do is we're going to open up an Explorer view, so hit 8 on the keyboard here, and you should be in an environment scope. If you're not, just click up here on this button, and just make sure that you click on environments here. Okay, so here's the current environment. All right. So what I want to do now is I want to go under the operators folder, expand that, and you'll see that I have one operator, the physics dynamic operator. Okay. So I'll click on this little icon here to open up the PPG. Likewise, I could always just select the operator and hit enter on the keyboard to open up the same PPG. All right. So this is the simulation accuracy. This is where you control the performance and the speed and the accuracy of the simulation, the dynamics engine. In this case, PhysX. In this case, PhysX. Okay, so we have two different tabs here, and the main tab we're concerned with is the simulation accuracy. We have a substeps parameter, which is by default set to 4. Now you can increase this to a very large amount. Now, the more substeps you add to this, the longer the simulation is going to take to calculate. In this case, it doesn't take long to calculate because it's a very simple simulation. You just have a cube falling on top of another flattened cube surface. But once we have more complex simulations going on with maybe dozens or even hundreds of objects colliding and bouncing off each other and stuff, you're gonna start to see how this substeps parameter comes into play. Now, here's the rule of thumb. The smaller the number of substeps in the simulation accuracy, the faster the simulation will compute, but the more inaccurate it's going to be. If you're having some kind of collision problems, or maybe some objects are penetrating through each other or just not reacting correctly, physically correctly, you may want to increase the substeps. Now, be advised that increasing the substeps is going to increase the calculation time for the simulation. So just be aware of that and keep that in mind. I would suggest increasing the substeps by very small increments just so that you don't increase your simulation speed by too much. The idea is to get it to as high a number as possible while keeping the simulation time as low as possible. So it's kind of a balancing act that you have to achieve. So don't just jump to suddenly 40 substeps. Start going up, increasing one substep at a time until you get something that's acceptable and looks good. Down here we have adaptive substepping. Now, this parameter is going to go ahead and control more substepping or adaptive substepping with your simulation accuracy. If you notice that the substeps increasing that just is not giving you the results that you need and you're still getting some kind of calculation errors, interpenetration, or any type of abnormal behavior with the dynamic simulation, you may want to turn on adaptive substepping right here. By doing that, you go ahead and activate this subdivision depth parameter here. What this does is what it does is the dynamics engine looks at your simulation. And if there's an area that's complex, a certain surface that's very complex, has a lot of polygons, is hitting another surface, and it needs to calculate more in that region, it'll adaptively calculate more of these substeps in that area. Okay, so it basically intelligently looks at the simulation and says, okay, this area here is a little bit complex and we're having some problems here. Let's go ahead and dedicate more resources to that area over there and get that knocked out and calculate some more substeps in that complex area of the scene. So that's what the subdivision depth will do. It'll determine how many of these subdivisions to go ahead and calculate when it needs more. Okay. Increasing this number is going to go ahead and drastically increase the amount of time it takes to calculate the simulation. So I suggest trying to use the substeps by itself. If you really can't get away from that and you run into problems, go ahead and turn on adaptive substepping. But keep it at a low amount. Start very, very low and test it and see if it looks good. If you're still getting errors or abnormal behavior, go ahead and start to increase it one subdivision depth at a time until you get an acceptable result, because the last thing you want to do is just crank up these numbers like this, and then you're going to have these long simulation times. We're talking about some very long coffee breaks. Okay, so you want to be careful about that and not go overboard with those parameters. All right, So that's going to do it for the simulation accuracy here. Just a couple of parameters, but they're two very important parameters that if you use them the wrong way, you can increase the simulation time by a large amount. And that's the last thing that you want to do. You want things to simulate quickly and accurately. You want them to look good, but also look good fast. Okay? So that does it for the physics dynamics operator. I'll end this video here, and in the next one we're going to continue digging through dynamics because there's just so much to cover, and we're just going to keep on going here and keep pushing on through. So I'll see you then.